Okay, now here we are once again, and we are under the topic of motion. But today we are going to look at the differential approach. We're going to look at the differential approach. So this section can only be handled when new students have done differentiation and some part of integration. The knowledge of integration and differentiation that we apply in paper 2 may not be quite deeper like that of paper 1. So here we apply a few of the concepts of differentiation and integration. So what you need to know is that let me make you remember. You have to remember something. You have to remember that if I'm given an expression y is equal to x to the power n, if you differentiate y with respect to x, that is dy dx, it is equal to, we drop the power, so it will be n, then we reduce the power by 1. But if you integrate y dx, when you integrate, you increase the power by 1, so it will be x n plus 1, and then you divide by the new power, which new power will be n plus 1, of course, plus a constant of integration. So that is it. Now, other thing that you can need to remember, we are going to be using terms like distance, terms like displacement, terms like velocity, terms like acceleration. But then by definition, you need to remember some of the concepts, right? You need to remember that from the mere definition of distance, distance is the length between points, given points, length between points, just length. But when we say displacement, displacement is the length between points in a specific direction. So for displacement, we specify the direction, right? So meaning displacement can have the magnitude and at the same time, the direction. Then when we say now velocity, I can start from here. Velocity is the rate of change of displacement. By definition, rate of change of displacement. So I'm assuming that my displacement is r. So when I say velocity, it is the displacement out of time. But because I'm saying rate of change, we say the r dt. So velocity is the rate of change of displacement. When I say rate of change, you have to divide by time. You have to divide by time, implying that if v is equals to the r by dt, meaning that to get velocity, when you're given displacement, you differentiate displacement with respect to time. That is when you get velocity. However, if you want now displacement itself when you're given velocity, by cross multiplying, you can see that v dt is equals to r, rather is equals to dr. So when you integrate both sides, when you integrate the r, you get r is equals to integral of v dt. So to get r, we integrate v dt. When you integrate v dt, you'll get vt plus a constant of integration. That is from velocity. Then the definition of acceleration is rate of change of velocity. So it is supposed to be velocity over time, but then we are saying rate of change of velocity. So if I'm given velocity, the moment I differentiate it with respect to time, I am able to get acceleration, implying that if I need velocity, if you cross multiply, you'll be having dv is equals to a dt. When you differentiate both sides, you can get your velocity. When you differentiate dv, you get v is equal to the integral of a dt. So our v is equal to, when you integrate a dt, you get at plus a constant of integration. So by having these, this is r, by having these expressions, by having these, we can now have a great feeling. So it's a matter of knowing what, when you integrate some functions, what you get. All right. All right, all right, all right. Then another thing that we need maybe to know about this thing is that when you're given maximum velocity and distance, they can talk about maximum velocity, maximum velocity, and the distance. When you're having maximum velocity and distance, we need to know when are these maxima obtained, okay? So this is attained when the acceleration is equal to 0. So this one is obtained when acceleration is equal to 0. But we know that acceleration is the rate of change of velocity dv dt, meaning that for maximum velocity, v maximum is attained when dv dt, which is acceleration, is equal to 0. So to obtain maximum velocity, this dv dt must be equaling to 0. And in this particular case, you can obtain the time for maximum velocity to be attained, and thus you can also get by mere differentiating and equating to 0, you can get the maximum time. Rather, you can get the time for maximum velocity to be attained, and then you can get the magnitude of velocity. We are going to look at examples very, very, very well. We're going to look at the examples very well. Then maybe also what you need to know, also distance is obtained, distance, this is velocity, maximum velocity first. Maximum velocity is obtained when the vdt is equal to 0. But maximum distance, or distance, is said to be maximum, simply when velocity is equal to 0. But you know that velocity is the rate of change of displacement, dr dt. So meaning that distance, I can call it s, is maximum when the r by dt is equal to 0. So this one enables you get time at which maximum displacement occurs, and then you can also get the magnitude of displacement. The same applies to acceleration. Acceleration is maximum when the a dt is equal to 0. So it is very, very, very easy. Then another thing maybe to record with the integrals and derivatives of trigonometric functions, we shall meet sine and cos somewhere. So if you're having y, here we are trying to remind ourselves, when you're having y as cos x, when you differentiate it, dy dx is equals to negative sine x. But when you integrate that y with respect to x, when you integrate a cos, you get positive sine x plus a constant. You should be able to remember this very well. If y is equals to sine x, the derivative of dy dx, when you differentiate sine x, you get positive cos x. But when you integrate it, when you integrate y, integrate sine x, you get negative cos x plus a constant of integration. So we shall be applying all these ideas in trying to do some of the questions. All right. Without wasting any single minute, let's look at the examples. Let's begin examples. Number 1. a particle is said to be accelerating at a uniform rate of 2t plus 4 meters per second square from rest at the origin. Find Roman 1 velocity attained at t is equals to 3 seconds, and Roman 2 distance traveled at t is equals to 2 seconds. So you need to be knowing exactly what you're given. After knowing what you're given, you cannot fail to get what they want. So from the observation, a particle is said to be accelerating at a uniform rate of this, meaning they have given us acceleration. So I'm given acceleration as 2t plus 4, but they have said from rest at the origin, meaning that at time is equals to 0, velocity was 0, displacement was 0, everything is 0 because it's from rest. So if you're given acceleration and you need velocity, we say that to get velocity, we integrate the acceleration, so a dt. So it will be the integral of acceleration 2t plus 4 dt. And this is equal to, when you integrate that, 2t squared over 2, 2t squared over 2 plus, when you integrate 4 with respect to time, you get 40, then of course plus a constant of integration. Now, at time is equals to 0, when time was 0, because we need to get the value of c, when time was 0, this is velocity, also velocity was 0, all right? Implying that if you substitute all those ones here, velocity is 0, is equals to, this is 0, this is 0, so it is 0 plus c, meaning that c is equal to 0. Then bring it here and get the value of velocity. So velocity would be equal to, it would mean that, it would imply that velocity is equals to, this one will cancel, so we have t squared plus 40. But they want us to find velocity at t is equals to 3 seconds. So at t is equals to 3 seconds, our velocity is going to be equaling to t squared, which will be 3 squared plus 4 times 3. So this will be 9 plus 12, and we shall get 21 meters per second. Is it okay?
It is okay.
Okay, that is Roman 1. Roman 2, they want us to get distance. Now, to get distance is derived from displacement. So we say that displacement is the integral of velocity dt. Integral of velocity dt. So now the velocity we shall consider is that velocity after substituting the value of c, not this. So it will be r is equals to integral of t squared plus 4t everything dt. So our r is equals to t cubed out of 3 plus 4t squared over 2, 4 t squared out of 2, then plus a constant of integration. But remember, they say that at time is equal to 0, from rest, even the displacement was 0, implying that 0, when you substitute here, is equals to 0 plus c. So 0 plus c, implying that our c is equal to 0. So when c is equals to 0, you can get our r when you have substituted. So our r at time t will be t cubed out of 3 plus 2t. But they want us to find distance when time is equals to 2 seconds. So at t is equals to 2 seconds, it would mean that our r is equals to 2 cubed over 3 plus 2 times 2. So it will be, no. This is, I forgot a square here. So it will be 2t squared. So it will be the same as 8 over 3 plus 8, which will be, this is 24 plus 8, 32 over 3, which is 10.6 meters. 10.6667 meters. Is the number okay?
It is okay.
Okay, so now we can have the second question done. We can have the second question done. The second question is a particle moving with velocity 2I plus 3j meters per second is accelerated uniformly at a rate of 3ti minus 2j meters per second square from the origin. From the origin, meaning that this is the velocity at the origin, this is acceleration from the origin. Find the Roman 1 speed reached by the particle at time is equals to 4 seconds to distance traveled by the particle at 2 seconds. That is the question. And without wasting time, let's tackle it. So we have been given acceleration. With acceleration, we can get velocity, the speed. So we are given, this is Roman 1, we are given acceleration as 3ti minus 2j meters per second square. So we need speed. So we know that velocity is equals to integral of acceleration dt. So it is going to be integral of 3ti minus 2j dt. So this is the same as 3t squared over 2i minus, when you integrate 2j with respect to t, you get 2tj plus a constant of integration. That is our velocity. But when time was 0, the velocity was this, because they told us that it is starting from the origin, meaning at time is equals to 0. So at time is equals to 0, velocity was 2I plus 3j. Substitute here. So it means that v, which is 2I now, when you substitute, you will have 2I plus 3j is equal to, when time is 0, this is 0, this is 0, so we shall have 0 plus c, implying that our c is equals to 2I plus 3j. When you do substitute, we shall have our velocity as 3t squared over 2 I minus 2tj, then plus c, which is 2I plus 3j. So this one will come out to be 3t squared over 2. You factorize those of I plus 2, everything into I, then plus those ones of j. We shall have negative 2t, this one, then plus 3, everything into j. That is our velocity. But they want that distance when time is 4 seconds. So when t is equals to 4 seconds, our v is equals to, show me how you have substituted. So it will be 3 times 4 squared over 2 plus 2, everything I plus negative 2 times 4 plus, of course, 3, everything j. So this is 1648 over 224 plus 226. So we shall have our v as 26I plus, when you look at this, this is negative 8 plus 3, which is minus 5j. But remember, speed, they need speed. Speed has only a magnitude, but has got no direction. So we shall get our speed as the magnitude of v, which is equals to the square root. When you're looking for the magnitude of a vector, we square the entries of I, j, and k if given. So 26 squared plus negative 5 squared. And this 25. It will give us the final answer as 26.5 meters per second. Is that part clear?
It is clear.
Good. So when they need distance, you have to be very careful. To get distance, we integrate velocity. But the velocity integrate is that velocity after substituting the value of c. So we shall integrate this velocity to get distance. Since it was from the origin, didn't mean that the displacement at the origin was 0. Okay, so from velocity is equals to, it was 3t squared over 2 plus 2, then I plus negative 2t plus 3j. So we know that our displacement will be equal to the integral of v dt. So it is going to be equal to the integral of velocity, 3t squared over 2 plus 2I plus negative 2t plus 3j, then everything, of course, we are integrating it with respect to what? To t. So this is the same as 3t cubed over a 3 we'll find down at 2, so over 6 plus, when integrate at 2 with respect to time, it is 2t. This is I plus negative 2t squared over 2. We increase the power and divide by the new power, then plus 3t, everything j, plus a constant of integration. But to get this constant, you have to look at the initial stages. At time is equals to 0. At time is equals to 0, our R was also equal to 0, the position was equal to 0. What does it mean? It means that 0 is equal to 0, all this will become 0, and all this one will become 0, then C, meaning that C is also equal to 0, meaning that our R is going to be equal to, we reduce it, to be 2t cubed over 2 plus 2t I plus negative t squared, then plus 3t, of course, j, that is the value of R. So having gotten the value of R, then we go at t is equals to 2, because they told us to find a distance at t is equals to 2. So at t is equals to 2, our value of R will be equal to 2 cubed over 2 plus 2 times 2, everything I plus negative 2 squared plus 3 times 2. Then everything here is j. So when you look at this, our R will be equaling to, this is 8 over 2 plus, this is 4 plus 4, that is 8i, plus this is 4. Sorry, negative t squared. Negative t squared. Oh yeah, so it is negative outside, then t squared. T is 2 squared, that is 4, times negative 4 plus 6, that is 2. J. This is R, but they need distance. Distance is the magnitude of R, because it must have only magnitude, so which is the square root of 8 squared plus 2 squared. So it is 64 plus 4 the root of 68, 8.25 meters. Is it okay? Is this okay?
Yes, it is okay.
That is good. Example 3. Example 3. So let's do this. It seems a bit tricky. A particle has an initial position vector, of 7i plus 5j meters. The particle moves with a constant speed, a constant velocity, moves with a constant velocity of ai plus bj meters per second. And 3 seconds later, its position is 10i minus j meters per second. Find the values of A and B. Find the values of A and B. Find the values of A and B. Now, here in this question, we are given the position vector initial position vector. And then we are also given the velocity. So we are given velocity as AI plus BJ. So, implying that at time t, seconds, the position vector let me call it position vector S will be equal to the integral of velocity. This is the, like we've been using R, but now we're using S. So S will be equal to the integral of AI plus BJ dt, which is going to be, when you integrate AI with respect to t, you will have AIT. So that I can say AI plus BJ, since all of them will have t, then I say t plus a constant c. But at t is equals to 0, when time was equal to 0, okay, they say that the particle has initial position of 7i plus 5j. So it would imply that at time is equals to 0, S was equaling to 7i plus 5j. What does it imply? It would imply that when you substitute here, you have 7i plus 5j is equal to, all of this would be 0 plus a constant. So the constant is 7i plus 5j. What does it imply? It implies that our S is equal to AI plus BJ T plus a constant, which is 7i plus 5j. All right? But then they're saying that 3 seconds later, its position is 10i minus j. What does it mean? What does it mean? It means that after 3 seconds, all right, the value of S is equals to 10i minus j. Its position is this, meters, not meters per second, meters. So the position is this, meters. Here it was this, meters. So it means that if we substitute here, 10i, it will be 10i minus j is equals to AI plus BJ. Now time has been specified as 3 after 3 seconds. So 3 plus 7i plus 5j. Implying that if we work on this well, we shall have 10i minus j is equal to, this is 3ai. We can correct the i's together, so it will be 3a plus 7i, then plus 3b plus 5, then everything j. So to get the values of a and b, we can equate corresponding unit vectors. Equate corresponding unit vectors. So for I, this side we have 10, the corresponding unit is 10. this side for I, we have 3a plus 7. So you can solve, you have 3a is equals to 3 and your a is equals to 1. For j, the corresponding unit vector this side is -1, and this side we have 3b plus 5. So when this one comes, this side we have -6 is equal to 3b, and we have your b as -2. Is it okay? Is it okay?
Yes.
Okay, I'm having more 2 questions to do, if not 3. I'm having more 2 questions to do so that we master the skill. So I may do more 2 or 3. Here comes this one. This is number what? Number 4. Yeah. Number 4. A particle of mass 2 kilograms initially at rest at 0, 0, 0 is acted upon by force 2t 40 newtons. Find Roman 1, its acceleration at time t. Roman 2, its velocity after 3 seconds. And then finally, the distance the particle has traveled after 3 seconds. This is the most interesting question because it is going to help us discover most of the important aspects. Solution to this question: you're given mass and force. From Newton's second law of motion, we know that force is equals to mass times acceleration. So it means that 2t 4t, that is force, is equals to mass, which is 2, then s. So acceleration is equal to, we divide by 2, so it will be t 2t. That is acceleration. Since force was given in units and this in units, so it is meters per second square. And since they say that time t, it means that it has to keep any time. Or one can write it as acceleration is equals to ti plus tj plus 2tk meters per second squared. This is the column form, and this is the row form presentation of vectors. Yeah, good. Roman 2, they want its velocity. With acceleration, you can get velocity. So velocity is the integral of acceleration dt. So velocity is the integral of acceleration, which is ti plus tj plus 2tk with respect to t. So when you integrate that, you get t squared over 2 I plus t squared over 2 j plus 2t squared over 2 is the same as t t squared over 2t squared over 2, it will keep here as t squared, then k, then plus a constant of integration. But since it is initial at rest at 0, 0, it means that even at time this is the displacement, is displaced at 0, 0, but it was not moving since it is at rest. So at time is equals to 0, velocity is 0. And when velocity is 0, it means that 0 velocity is equals to this is 0, this is 0, this is 0 plus c. So 0 plus c, implying that c is equals to 0. Hence, our velocity is equal to t squared over 2I plus t squared over 2j plus t squared k plus a constant which is 0. That is it. But then they want velocity after 3 seconds. Okay? Velocity after 3 seconds. So that is, they want v at t is equals to 3. All right, so at t is equals to 3 seconds, mean that our velocity is equals to 3 squared over 2 plus 3 squared over 2. This is I, this is j, then plus 3 squared k. So our v is 9 over 2I plus 9 over 2j plus 9k. As simple as that. Then distance, the particles traveled after 3 seconds. To get distance, that is part 3. Of course, to get r, we have to integrate velocity dt. And we already have the velocity. The velocity we are having is this in terms of time. Here, so it is t squared over 2I plus t squared over 2j plus t squared k dt. So when we integrate this, we shall get t cubed over 6, because at 3 will come down to find this at 2, I plus, the same applies to that, t cubed over 6j plus t cubed over 3 k plus a constant of integration. But initially it was positioned at 0, 0, 0. So at time is equals to 0, also r was equal to 0, implying that when you substitute, you will also get c as 0. So r at time t is going to be equal to t cubed over 3I plus over 3 over 6 plus t cubed over 6j, then plus t cubed over 3k. But they want you to get that, they want you to get distance when it has traveled already after 3 seconds. So I want every viewer to do that. Substitute 3 seconds where time is, then after take the magnitude, because they need distance. And I want you to find out if your answer will be 11 meters. I want you to find out if your answer will be 11 meters. All right. Is it understood?
Yes, but on this last equation, it's supposed to be t squared, t squared. These last t's.
Supposed to be t squared.
Hey, you had integrated it.
I integrated it.
I have seen it.
Okay.
Yes, okay.
Then let's have some other question done. Especially when they have given you the direction. Number 5. A particle with the position vector (10i) plus 3j plus 5k moves with constant speed of 6 meters per second in the direction I plus 2j plus 2k. Find the distance from the origin after 3 seconds. Somehow tricky, but very easy. Because the only thing is that they have given us the magnitude of d of speed, and they have given us the direction. So we need to know how we get the velocity. Now, allow me let my d to be the direction of the particle, and also allow me let u to be my speed of the particle. Allow me let v to be the velocity of the particle. Now, to get velocity, because they have given us speed and the direction of the particle. So to get the real velocity, not the speed, to get the real velocity, we dot u with the direction. Rather, we dot u and d cap. We are going to see how we get d cap. D cap is equal to distance direction, because we let it to be d. So it is direction over magnitude over direction. So you need to know this. To get v, you get the velocity, the speed, which is 6. You dot it with the d cap. This is the directional unit vector. Now to get this directional unit vector, we get direction itself over the magnitude of direction. So, but direction itself, the magnitude of direction itself, is equal to the square root of direction. Now the direction is given as I plus 2j plus 2k. So it is going to be 1 squared plus 2 squared plus 2 squared. This is 489 under magnitude to give us 3, implying that our d cap is going to be equaling to d, which is 6, out of the magnitude. No. It is d, the real direction, which is I plus 2j plus 2k out of the directional magnitude, which is a third. So we divided by 3, so it gives a third, implying that the real velocity will be equaling to u, which is 6, times the directional unit vector, which is a third, I plus 2j plus 2k, which will give 2i. I think you can expand this. This one will reduce to 2, so it will be 2i plus 4j plus 4k. This is our velocity. Now, remember they want the distance, but you know, to get distance, to get r, it will be the integral of v with respect to time. Okay, so my r will be equal to the integral of 2i plus 4j plus 4k with respect to time dt. So this is going to be r is equals to 2ti plus 2tj plus 2tk, of course, plus constant. I told you to get constant, you have to bring in at time is equals to 0, what was r? A particle with position vector. So it was this position vector. 10i plus 3j plus 5k. So implying that this one, we shall have 10i plus 3j plus 5k is equals to, we substitute time as 0, it will make 0 plus constant. So our constant will still be 10i plus 3j plus 5k. Now implying that they want the distance from the origin after 3 seconds. So we are going to have our r first as 2t we shall, since we shall add a constant, so we shall correct a 10 there. 10, it makes an I plus 2t again plus 3, that is j, then plus 2t plus 5, that is k. Actually, this was supposed to be 40k. So this is 40. Now, at time is equals to 3, we shall have our r as, we multiply 3 for t. So this will be 6 plus 10, which is 16i. Substitute. Plus, this is 6 plus 3. No. Yeah. It will be I don't know why I'm writing a 2 instead of a 4 here. 40, so it is 12 plus 3, that is 15. J, then plus finally 12 plus 5, that is 17k. So they need a distance. The distance is equals to the magnitude of r, which is 16 squared plus 15 squared plus 17 squared. When you check that, you get the root of 770, which is going to give you 27.75 meters. Is it okay, Stable?
Yes.
The only trick is on the direction. So I guess let me first put this question. I see if you can do it, I leave it as the homework. It's supposed to be number 6. An object of mass 5 kilograms is initially at rest at a point whose position vector is negative 2i plus j. If it's acted upon by a force F, which is equals to 2i plus 3j minus 4k, find Roman 1, the acceleration of the object Roman 2, its velocity after 3 seconds. Roman 3, the distance from the origin after 3 seconds. Can it be done?
Yes, it can be done.
Yeah, because they have given you mass and a position vector where it is placed, that is r naught at the origin. They have given you the value of r at the origin and they have given you force. So you can first get acceleration and then you continue. And then you continue. Finally, you can try this. It came in Unable of 2018 as number 10, free marks. And try this also. Have you finished copying the other? Have you finished copying the other?
Yes.
Copy this, a particle of mass 4 kilograms starts from rest at a point 2i and a 3j plus k meters. It moves with acceleration a, which is equal to 4i plus 2j minus 3k meters per second square when a constant force acts on it. Find the Roman part A, force F, part B, velocity at any time t, but C work done by the force F after 6 seconds. The trick is on the last part because you can get force since you have mass and acceleration. But how do you get work done? How do you get work done? You know, to get work done, you get force times distance. So if you have force, then you get distance also and dot them together. Actually, it is force times distance. Force dot distance. So you'll have the vector of force, maybe x, y, z. You dot it with the vector of displacement r, maybe rp2. Do you get a point? Do you get the point?
Yes.
Get force and displacement,
Yes.
you dot them together and get. You know, when you're dotting, you get x times r plus y times p, isn't it? Then plus z times q. It will give you the work in joules. So by doing those questions, you will not meet any problematic question in this area. Is it okay?
Yes, it is okay.
Okay, let's call it a night. See you next time.